section 1.6 is all about the design of experiments. So on Wednesday, we went over section 1.2, I believe, that had observational study versus experiment. And then we talked about the different types of observational studies, but we never talked about the different types of experiments. Experiments are a little bit more in-depth. There's a lot more going on, so they get their own section, okay? So this is actually the last section in chapter 1, all right? So after today, we're officially done with chapter 1. Your first test, if you're curious, is over chapters 1, 2, and 3. So after today, we're done with a third of what our test is going to cover. So let's look at this. So objective 1, describe the characteristics of an experiment. An experiment is a controlled study conducted to determine the effect that varying one or more explanatory variables or factors has on a response variable. The treatment is any combination of the values of each factor, and the experimental unit or subject is a person, object, or some other well-defined item to which a treatment is applied. So the key word, remember, with experiment is you're controlling. Observational study, you just observed and recorded, and that was about it. All right, so we already kind of talked about the explanatory variables and the response variables. The response variables are what you're studying and measuring. The explanatory variables are what is doing the changing, okay? So if I'm studying the growth of my sunflower plant, the response variable is the growth, but the soil and all that other stuff is an explanatory variable, right? So in here, they have like, 2 other definitions that are bold-faced but don't really have their own definition, okay? So the treatment is the factors. So those are actually the explanatory variable, okay? So the treatment is the explanatory variable, and the experimental unit is who you're doing it on. It's your samples, right? From sample. So in this case, when I keep using my sunflowers as my examples, my sunflowers, each of them themselves are the experimental units, and then the treatments are going to be all those factors that affect their growth. So soil, sun, water, fertilizer, that kind of thing, all right? Control group. The whole idea is you can't go get excited and give every single sunflower this fertilizer that you want to test because you're like, oh, they all grew great, but you gave them all the same stuff. Well, did they all grow great because that's just how they grow, or because of your fertilizer, right? So you have to have this control group, this kind of baseline where, you know what, nothing's happening to them, so let's just see how they would grow without the fertilizer. And then those that grow with the fertilizer, we can compare, okay? So the control group is just your baseline, okay? They let you know if you weren't doing anything, what would have happened, okay? So like if I wanted to make you guys one of my control groups, I'd just say, come to class and take notes, but don't do your homework and don't study. You would be my control group, and then everybody else, I'd say, okay, study, do my math lab, all that stuff, and you would be my treatment, all right? So don't you think there'd be a definite change in how you guys did on your test? Yeah. All right. Placebo, this is something that we kind of mentioned last week. Placebo is a harmless drug, but the whole idea of a placebo is everybody needs to think they're getting help, okay? So if I'm testing a medicine, everybody has to think that they're getting the medicine so they can reply accurately. Because if you know you're getting a sugar pill and you know you're getting the headache medicine, you're like, oh yeah, my headaches are great, they're so much better, you know. But this way, everybody gets it. I know or don't know who got the placebo, but ultimately everybody thinks they're getting that drug. And so I'll get accurate results that way. All right. Last definition in Objective 1, there's 2 of them. There's single blind and double blind. A single blind experiment is one in which the experimental unit, so that subject that we're studying, does not know which treatment he or she was receiving. So that's the one person. That's why it's called single blind. Double-blind experiment is an experiment in which neither the subject nor the researcher in contact with that experimental unit knows which treatment the experimental unit is receiving. So I kind of go back to that Grey's Anatomy where they're testing for Alzheimer's or whatever. Technically, that was supposed to be a double-blind. Like Meredith wasn't supposed to know whether she was giving the accurate drug or not, or whether it was a placebo. So neither her nor Richard's wife, I forget her name, Adele or whatever, neither one of them knew, okay? Or if I'm testing this migraine medicine, that would be called a double blind. So if I was testing migraine medicine, how could I turn that into a double blind? There's some researcher in a lab coat that says, Molly, take these drugs to your students. So I just get the tray and I give them to you. Do I know what you're getting? No. So when both of us don't know, that's double blind. But if I'm like, nope, you're getting the placebo, you're getting the medicine, and so forth, you guys are the single blind, okay? Either case, the subject never knows, right? The subject never knows. And sometimes those that are administering know or don't. All right, so what's objective 2? It goes in depth. It's not very exciting. I'm sorry, none of this is very exciting, section 1.6 especially. It just goes into depth with, like I said, that scientific process, that method that we did with science experiments, okay? So number 1, on your yellow sheet, you have to decide what you're going to study or what you're trying to solve, right? After you do that, you're going to decide, okay, how am I going to record it and so forth, and you made a claim, okay? You are saying, I watch this much Netflix in a day, or I drive this many miles in a day, or I work out this many minutes in a day, okay? You make a claim, or it's also known as a hypothesis. Have you guys heard of that before, a hypothesis? If-then statement. After you make the claim, you got to decide, okay, what can affect this claim? Like, what kind of factors are out there? So there's 3 types. There's fixed, there's manipulated, or uncontrolled. Fixed, manipulated, or uncontrolled. I will talk about those all down here, but I'll just say them real quick. If you're studying something, there's going to be tons of factors that might affect your response variable, but there's only really one that you're studying. So again, go back to my sunflower. I want to know how great my fertilizer is, okay? But what else is going to affect the sunflower's growth? Rain, sun, soil, and so forth. So I would fix that. I would say, okay, everybody has the same soil, is in the same sunlight, has the same amount of water, okay? So all of those things that affect the plant growth would be fixed. What am I going to manipulate? Who gets the fertilizer and how much, all right? And then there's some things that are uncontrolled. We'll talk about that in a second, but like I can't control how good these sunflower seeds are, you know? So we'll talk about how we handle that. All right, 3. Determine the experimental units. Who are you studying? How are you going to get them? And again, the bigger the better, but it's usually limited by time and money. So you can't always ask everyone. And just down here it says there's techniques to calculate the number of experimental units that have to be legit. So what am I making you do on the yellow sheet? You don't know it yet. You don't know what that magic number is, but I'm making you think of something daily or 2 to 3 times a week. Weekly is not enough because that's only 16 weeks of data that we would have. All right, down here are the ones I was kind of talking about. So some of these fixed things, we're going to fix the levels at a constant level. So we're going to control those. Again, factors of not of interest. So the soil, the sun, the water, I have to fix them. I have control over them. Everyone's going to have the same soil, be in the same sunlight, and get the same amount of water. Okay? For factors of interest, I'm going to manipulate them. Manipulate is a type of control, but it has a little bit of movement with it, right? Control is just like dead set. Manipulate means you can kind of screw around with them a little bit, right? So some of these sunflower seeds aren't going to get any fertilizer. Some are going to get this much, and some are going to get this much, okay? So I'm studying that. That's the factor of interest, and I'm going to manipulate who gets what. Last one, what do you do for the uncontrolled factors? For example, what if my sunflower seeds I have no control over the sunflower seeds and how good they are? The best thing you can do is randomize. Randomized. If I truly want to have a good experiment, guys, I will not just go to Home Depot and get a pack of sunflower seeds. I'll go to Lowe's, I'll go to Menards, I'll go to True Value. I will randomize where I'm getting these sunflower seeds. That way, you know, everyone has a chance to kind of grow. Because if I don't, and I just go to Menards and there's a sucky batch of sunflower seeds, I'm going to think my fertilizer sucks. But really it was just the seeds, okay? So for factors of uncontrolling, you always randomize. You always randomly choose, all right? Go ahead and flip it to the top of page 11. Does anybody have any questions so far? Like I said, it's not very interesting, but I want to make sure, all of this you could read in the book, but I want to make sure I just put my own little spin on it so it makes sense. Once you know your claim, once you know what you're studying and you have controlled, manipulated, and randomized everything, you get to conduct the actual experiment, okay? And the key thing here is replication. So that just means large sample size, guys. And you may do it over and over and over again. So if I'm doing sunflower seeds, I'm going to have a large sample size, but I'm not going to just grow them for a day and say, my fertilizer sucks, nothing grew. I'm going to do it day after day after day. You're going to record day after day after day, okay? So we want to have a ton of information and ton of data. Once you get that, guys, you're going to collect it and process it, and then you can test your claim, okay? Once you see what you found, you can say, oh my gosh, my sunflowers that had the fertilizer were twice as tall as those that didn't. So what could be the claim that you can make? My fertilizer's good, you should buy it. Or if there's only like an inch difference and not every plant grew more, you're like, I don't know how good the fertilizer is. Remember, inferential statistics is always when you apply to the population. Apply to the population. It's when you take what you find in a sample and apply it to the whole population. How can this help you? Is anyone brave enough to share what they're planning on studying on their data sheet that might help them with something? Smoking, cussing, drinking water, anyone? What are you doing? Sleeping. So do you think you need more sleep or less sleep? More sleep, okay? So he is on the lookout like, hey, I probably need to be getting more sleep. How much sleep am I really getting? So he's going to record every night the hours of sleep he gets and notice, oh my gosh, this is really low. And so he's going to take this data and say, okay, if this semester I slept that few of hours, this is probably what I'm doing with most of my life, I may want to sleep more. You know, like you just take your semesterly data and apply it to the population. Can I ask you what your claim was? How many hours of sleep a night do you think you get?
Like minutes.
Oh, minutes, okay. Yeah, that's awesome. And it's going to be easier to do that because when you like wake up and it's been at 3.5 hours, you can put, 210 minutes or whatever.
So before 20, so that's like
7 hours? 7 hours, okay.
7 hours.
Okay, awesome. All right, so those are the steps. Make the claim, decide what's going to change your variables and factors that you're studying, conduct the experiment, and apply it to the population. All right, so what are the different types? So we had cross-sectional, cohort, and case control when it came to observational studies. We only have 2 types of experiments when it comes to experiments. Completely randomized design is one where this is what I think of as an experiment, okay? I want to study my sunflowers, so I get all my sunflower seeds. This half gets my fertilizer. This half just gets, water, soil, sun, no fertilizer. At the end of the experiment, I'm going to see who grew better. I mean, is that what you think about? Like when you have to do, some people are just going to be flat line, baseline. Other people are going to get this special thing happening at the end. We're going to come and see which one did better, okay? And it's randomly. You randomly assign who goes where, all right? Next one, match pairs design. It's an experimental design in which the individuals are paired, okay? The pairs are matched up so they are somehow related. All right. What does that mean? It means I might take a family and I have a pair, a husband and a wife. I might have an individual that has a pre and post test. I might have twins, okay? There's some kind of reason why, I don't just randomly choose 2 people. There's a reason why I'm pairing you, okay? So I'm going to have all the people, and I'm going to randomly decide the pairs, and then I'm going to split the pairs up. So group 1 are all the husbands, group 2 are all the wives. They get the treatment, they don't. At the end, we compare results, okay? So here it's just, I'm randomly splitting you up half and half, where here you're paired and then split, all right? So let's see, I think on page 12, guys, it does a good example of showing how we can do this. All right. It says an ad for Crest White Strips Premium claims that the strips will whiten teeth in 7 days and the results will last for 12 months. Everybody know what Crest White Strips are? Are we even doing those anymore? I feel like we're going a little bit higher up and actually getting trays and going to dental offices to get it. Anyway, so supposedly they can whiten your teeth in a week and that lasts a year. A researcher who wishes to test this claim studies 20 sets of identical twins Within each set of twins, one's randomly selected to actually use the Crest White Strips Premium in addition to the regular brushing and flossing, while the other just brushes and flosses like normal. The whiteness of the teeth is measured at the beginning, after 7 days, and every month thereafter for 12 months. Bless you, okay? So let's look at A first. What type of experimental design is this? Is this their completely randomized design where I get these 20 patients and randomly split them up? Or is it matched pairs design where I get these 20 patients but they're paired up and then I split them up? Matched pairs. What is the key word? Who do we have? Identical twins. So this is matched pair. Right? We're asking twins. So there's a matching first before we split them up. All right. B. What is the response variable in this experiment? Remember, the response variable is what's being changed and what you're studying. So what's the whole point of this experiment? The whiteness of the teeth. You got it. Whiteness level of the teeth. All right. The treatments, guys, are your explanatory variables or your factors, okay? So what does that mean? It means if we're really studying the whiteness level of our teeth, what are things that we're having our sample do that can affect the whiteness of your teeth? What's one of them? The white strips, right? And that's our factor of interest, right? What else are we having them do that affects their whiteness? Brushing and flossing. And that's not of interest? That's kind of like our placebo, right? Like that's our baseline. Still brush and floss your teeth, but these white strips are really what we want to see their magic happening. Is that okay? I'm going to bump this up if that's okay. D. What are other factors, controlled or uncontrolled, that could affect the response variable? So this is where, does anybody remember my favorite vocab word? Good job. Points. You shouldn't remember that, but that's awesome that you did. That lurking variable, right? There's so many more variables that affect how white our teeth are than brushing, flossing, and white strips, right? So what are some of those things that can affect how the whiteness of our teeth? Smoking, yes. What else? Caffeine. Diet. Yeah, I never thought about that. Just the composition of the teeth, is that a good way to say it? Composition? Like I have a fake tooth. This tooth's fake. You would never tell. It's a crown. So composition of teeth, should we say that? Does that make sense? Are they real? Are they dentures? Are they crowns? Are they bridges? That kind of thing. Two other ones I want to say for sure. This I probably couldn't control, right? Like I can't choose whether you have a fake tooth or not. I'm not going to tell you what to eat or drink. But there's a couple things I can control. Your efficiency of brushing and flossing, right? I can say you had to brush your teeth for 5 minutes and floss every tooth. Who flosses daily? I'll go that direction because I don't think there's many of us. We're rare. Do you know that? My husband thinks I'm crazy. He's like, why do you floss? I'm like, I had a speech about that in college. I'll tell you why later, right? So how well you brush and floss is going to definitely affect it, right? And then there's one other one that we cannot control, but my hint to you guys is, why do you think they picked twins? Same DNA, same genetics, right? So genetics definitely affect. Like, do you have that friend that eats like crap, like brushes maybe once a day and has like no cavities? And you're like brushing and flossing daily and you have like 5, okay? Sometimes they just, gosh darn it, have good genes and you can't help that, all right? Or bad genes and you can't help that. All right, so that kind of gives us the answer to E, right? What might be an advantage of using identical twins as subjects in this experiment? They have the same genes, right? Same genetics. In this case, guys, we need a baseline data. It would be great if we could be the one person, but we can't, because the second we put white strips on, we have no idea what our teeth would look like if we hadn't put white strips on, right? Like, it's like, oh, my teeth got whiter. I'm like, well, maybe they would have just gotten whiter with your brushing and flossing. So we have that matched pair to have that baseline, that controlled, and it doesn't make sense to randomly pair us up. It makes sense to maybe pick twins or even siblings where you have the same genetics, and it's as close as someone not brushing their teeth or someone that's not using the white strips and someone that is. And at that point, you can compare.
Okay, wouldn't toothpaste be another factor?
Yeah, the type of toothpaste.
Charcoal toothpaste.
Yes. So we'll put type of toothpaste. What kind did you say you use?
I use charcoal to help whiten it.
Really?
Yeah.
And I know charcoal is kind of making a comeback as far, I shouldn't make a comeback, I don't know if it was ever here, but it's a really big thing with charcoal soap and so forth. A lot of toothpastes you can have with or without whitening, right? So if you're not using whitening and he is, so that's something that we probably would control. Like everyone's using this toothpaste this many times and so forth. Are there any questions there? All right, I'm going to stop it.